Okay, welcome to the Chapter 3, Lecture number 2, Programming in Simple Control Structures. Control structures and control statements are similar. They are ways that we are able to organize our code so that we can have conditions put in place and kind of make the code think for itself. So what we're looking at doing here is what we have been doing in the past is using do in order and do together to control the way the instructions are executed. We will add a couple of more into that. So we will use conditional execution as well as repetition. Conditional execution is where some condition is going to be checked by the program. So whatever, if A is A greater than B, and if that's true, do this. If it's false, do something else. Conditional execution is extremely useful when doing games, simulations, real-time controls, and even robot systems. Now, an example of this is we're going to apply this to our first encounter world that we've been working in. So if we take a look at that world, as the robot moves closer to the alien hides behind the rocks. So we want to check a condition. Is the robot too short? Is robot too short over the rock? That's a typo in there, I didn't even realize. And then perform the action based on whether or not that condition is true or false. So we will use what's known as an if-else. So if it's true, do this, otherwise do something else. So an if-else control statement is basically going to be testing a condition, determining whether or not it is true, doing one action if it's true, doing some other action if it is false. If we were to put this into storyboard terms, we're looking at if the spider robot is shorter than the rock, then if that's true, spider robot neck move up, spider robot neck move down. If that is not true, then don't do anything at all. The condition of the if statement is known as a Boolean function because it's going to yield us a true or false value in return. Let's take a look at the demo. I will show you the code and then I will execute the program so you can see exactly what's happening. All right, so here's the code and here's the section right here where here's the if else. The if else is right down here. We would just drag it up and throw it into our code in our method window. So now the condition that we are going to check is if the spider robot is shorter than the rock, then do in order spider robot neck move up 0.2 meters for a duration of 0.5 seconds. And then spider robot neck move down for 0.2 meters for a duration of 0.5 seconds. If that is false, then do nothing. So let's see what happens when I play the world. Okay, so that was the condition turned out to be true. So the spider robot's head moves up and down. If it was false, the spider robot's head would not move at all. All right, so let's move on. There's a different way of doing it. Let's take a look at a different scenario. In some cases, the built-in functions are not sufficient for what a condition that we want to check. So let's take an example of the built-in function is shorter than compares the heights of two different objects within the same world. Let's suppose, however, that we wanted to compare the robot's height to 2 meters. How can we compare the height of the robot to a specific measurement, in this case 2 meters? We can use relational operators in this case. So in this case, we would be in the world's details, we would be in the functions, and now we can use a relational operator to determine whether or not a condition is true or false. So in situations where you need to write your own comparison, we will use a relational operator. Relational operators are going to provided to us in the world's functions. So in this case, as you take a look at the slide, you can see is A equal to B? If A is not equal to B, if A is greater than B, if A is greater than or equal to B, if A is less than B, or if A is less than or equal to B, are sample relational operators. So let's take a look at the demo taking a look at the demo world, first encounter relational operators. Let me bring that one up on the screen. I'll have to open up this world. First encounter relational operators. All right, so if we take a look in the code here, I will scroll down until we find out where the relational operator is. Here it is. If the spider robot's going to move forward, spider robot distance to the rock. Oh no, that's not it. That's not it. My mistake. No, here's the relational operator. All right, so if the subject or the spider robot height is less than 2, then if that's true, have the robot's head move up and down. If it's not true, do nothing. Let's see what happens when we play the world. It turns out that it was true, so the spider robot's head moves up and down. If it was false, the robot's head wouldn't move at all. All right, relational operations are defined using world's built-in functions. We know that, we've already talked about that. Placeholder values are first selected for the A and the B components. Those are the two variables that are going to be compared for the relational expression. Then the placeholder values can be replaced by either a function itself or a number. Okay, the need for repetition. If something needs to happen more than once, the walking action is not realistic. The robot moves forward to the rock in the distance of several meters, but the legs are not sealing in the walking action the way that they're supposed to. So we need to repeat this action. So one way of doing it is do together, we have, and then do in order. This is the code that we wrote to have the spider robot's legs walk. But now the robot is moving forward only 1 meter. This block of code will have to be repeated again and again to animate the moving close to the rock. In this case, we use a conditional operator known as a loop. Loop is going to determine how often or how many times a particular block of code is going to be executed before it is done. All right, let's take a look at the demo as we use the first encounter with a loop statement in it. We open up that world, loop. All right, so here's the first encounter with the loop. Here's the loop. The loop condition is going to be 3 times. So 3 times we want this code to execute, which means it's going to be the walking motion for the spider. That's going to happen once, twice, 3 times, then it's going to move on to the next set of code instructions. So let's see how this plays out. Okay, so there we go. The walking motion happening more than once. It happens 3 times because that's what we designated it to do. We do that using a loop. We can get a loop control structure on the bottom of the screen right next to the if-else. All right, for the rest of chapter 3, then you are to read chapter 3, including section 2. Chances are you've already read chapter 3, or at least you should have, because we've been on chapter 3 for some time now. And review yourself simple control structures. Make sure you read through the tips and techniques. It can give you some possible suggestions on how to code some of your exercises and projects that you're going to have to do as assignments later on in the chapter. And then at the end, we will be doing chapter 3, section 2 lab. Okay, so make sure that you have completed, obviously, watching the presentation lecture and reading chapter 3. If you need to, go back and revisit some of the slides and some of the demo problems so that you can see how that code would look in a world if you needed to use it for whatever your instructions might be. All right, that is the end of the presentation lecture. So enjoy, and I will see you in class tomorrow.